Good morning, everyone. Myself, Pawan. I am pursuing BTech in Srinivasa Ramanujan Institute of Technology. Today, my topic is what is minimum spanning tree? Explain the algorithm. A spanning tree is defined as a tree-like subgraph of a connected undirected graph that includes all the vertices of the graph. Or to stay in layman's words, it is subset of the edges of the graph that forms a tree, where every node of the graph is a part of the tree. The minimum spanning tree has all the properties of a spanning tree with an added constraint of having the minimum possible weights among all possible spanning trees. Like a spanning tree, there can also be many possible MSTs for a graph. Properties of minimum spanning tree. The number of vertices in the graph and the spanning tree is the same. There is a fixed number of edges in a spanning tree which is equal to one less than the total of vertices E is equals to V minus 1. The spanning tree should be disconnected as in there should be only the single source of component, not more than that. The spanning tree should be acyclic, what means there would be any cycle in the tree. The total cost of the spanning tree is defined as the sum of the edge weights of all the edges of the spanning tree. There can be for many possible spanning trees for a graph. The minimum spanning tree has all the properties of a spanning tree with an added constraint of having the minimum possible widths among all possible spanning trees. Like a spanning tree, there can also be many possible MSTs for a graph. This is the example for minimum spanning tree for a directed graph. Mm. And this is one more example for minimum spanning tree. Algorithm of minimum spanning tree. Kruskal's minimum spanning tree algorithm. This is one of the algorithms for finding the minimum spanning tree from a connected undirected graph. This is greedy algorithm. The algorithm workflow is as below. First, it sorts all the edges of the graph by their weights. Then it starts the iterations of finding the spanning tree. At each iteration, the algorithm adds the next lowest weight edge one by one. Such iteration, the algorithm adds the next lowest weight edge one by one, such that the edges picked until now does not from a cycle. This algorithm can be implemented efficiently using a DSU, disjoint set data structure, to keep track of the connected components of the graph. This is used in a variety of practical applications such as network design, clustering, and data analysis. Kruskal's algorithm. Here we have a graph of A to B, B to C, C to D, D to E, E to F, F to G, G to H, G to I. This is the vertices, and we have edges and the final output A to C, A to C, C to B, C to F, again backside C to B, B to D, D to E, E to G, G to H, H to I. Here we have final output. Prim's Prim's minimum spanning tree algorithm. This is also a greedy algorithm. This algorithm has the following workflow. It starts by selecting an arbitrary vertex and then adding the adding it as the MST. Then it repeatedly checks for minimum edge weight that connects one vertex of MST to another vertex that is not yet in the MST. This process is continued until all the vertices are included in the MST. To efficiently select the minimum edge for each iteration. This algorithm uses a priority queue to store the vertices sorted by their minimum edge weight currently. It also simultaneously keeps a track of the MST using an array or other data structure suitable considering data type it is storing. This algorithm can be used in various scenarios such as an image segmentation based on color texture for routing as in finding the shortest path between two paths for a delivery truck to follow. Trims algorithm. These have we have example and final output applications of minimum spanning tree. Spanning tree can be used in a network designed to find the minimum number of connections required to connect all nodes. Cost of the connections by selecting cheapest edges. Image processing spanning tree can be used in processing to identify regions. Similarly, conclusion. The concept of minimum spanning tree (MST) is fundamental in graph theory and optimization. It helps and find the most efficient way to find correct nodes in a network with the minimum total cost. Thank you.